coming in. I'm very excited to see the new faces, some of the familiar faces. Thanks for coming back. And yeah, I'll give actually 2 more minutes for people to come here. Awesome. All right. So let's get started. Thank you for coming once again. We are here for 15th AI Dev Day by AI Camp. The QR code that you see here will take you to the LinkedIn post. And if you comment, I will run a raffle towards the end after our last speaker. And that way, I have 2 really good speakers for the 2 winners, whoever gets lucky through the raffle. So please post on the LinkedIn, the QR code LinkedIn post, spread the word. We would love to have more attendees and more interest in the community. So for the people who are coming here for the first time or who do not know what AI Camp is, well, we are basically a nonprofit organization with the aim of growing the AI developer community globally. And we want to bring in developers and anybody who is basically curious about AI or who are working in AI together. And we are spread all over the world. Like, for example, we have San Francisco chapter, we have Seattle, New York, Boston, Paris, London, India, and so on and so forth. We do the in-person tech events monthly in all these cities that I mentioned. And not just that, but we also have online webinars, workshops, hackathons, and so on. So if you're wondering how you could get involved in the community, well, there are several different ways. You could submit topics to speak and give a talk like how we have the one arranged today. You can, of course, sponsor the meetups, because guess what? The pizza was not sufficient today, and it's probably already over. We would love some more pizzas. So more sponsorships and more donations would be more than welcome. And yeah, the email address, as you see on the screen, is the one you can use to reach out for however you would like to get involved. Here's the chance for a community shout out. If you are looking for a job, if you're hiring for one, if you're looking for co-founders or any project collaborations, or would like to host events with AI Camp, please raise your hand and I'll give you the mic for like 30 seconds and you can tell us about it. And since I have the mic in my hand, I'll take a chance that I am looking for a developer advocate role. So if you're hiring and also sponsoring visas, please let me know. But yeah, anybody hiring? There we go. Okay. Any community shout?
Thank you. Hi, my name is James. I'm working on a few personal projects in the gaming area. I'm looking for a product-savvy person to bounce off ideas and potentially found a company put together. I'm very technical. So that's it. Thank you.
Thank you. Anyone else? Sorry, after that.
Hello, everyone. My name is Bernard. I am a senior machine learning engineer at Adobe, and my team is looking for a senior machine learning engineer with about 4 years of experience. So the job is already posted. So if you're interested, please reach out, and you know, we can talk, and you can also apply directly, and your resume will be reviewed. And if you qualify, yeah, you'll be interviewed. Thank you.
Thank you. I'm Will Adrian. I'm building a marketplace for AI agents where it's easy to put them onto shelf or find and bring to work to solve real business needs. I have million paying users in my other business, and I want all of them to get access to every agent which exists. So I'm looking for founding engineering team there So I have developers in Asia, but I want to have presence there, somebody with whom I can go to hackathons. I recently relocated here to visit this type of events. Thanks a lot for this. So Well Agent asked me if it's in your interest.
I didn't mean to rush you. Hey guys, my name is Gav. I just flew up from LA. Started my company about 2 months ago. Got funded today, so it's exciting. I'm looking for a full stack founding engineer. I have my CTO in the other event, and it's going to be our second hire. And we're working on an operating system for AI, so similar to the App Store, where enterprises can buy different AI apps and easily connect to all the data sources. So middleware for AI. Thank you.
Oh.
Hi, my name is Pian, founder of Emotions and AI coaching and upskilling startup. We have an AI coach that can give people real-time advice and tips and answer any questions. I'm looking for a CTO / possible co-founder. We're also looking for engineers as well. So you can find me Pian, Pian, like piano without O, Emotions on LinkedIn. We posted on Slack as well. Thank you.
Hi, everybody. My name is Gio. I'm the CEO of Light Software. We do AI consulting. So if you're looking for, AI consultants, a team of really professional ML engineers to help you build some really cool AI projects or help out in any way, you can find us at lightsoftware.ai. And we're also hiring AI engineers all the time. So lightsoftware.ai. Thank you.
Thank you. All right. So there is the QR. Oh, sorry.
Hi, everybody. I'm creating a company called Squared Automation. It aims at creating a very fundamental AGI by combining two AI agents, AI agent 1, AI agent 2, an AI agent that creates money through a SaaS or an e-commerce, and the AI agent that collects data and feedback this data to the first AI agent. And basically by creating this loop, if we can create one single loop that creates one single cache machine, then we can duplicate it indefinitely. So if you're interested in creating a very fundamental AGI, come speak with me.
Okay, last one.
Thank you very much. I'm trying to start a startup. I'm a Python dev with a machine learning that I can track hate contents. And the biggest reason for these hate contents when we see on the San Francisco streets is that every time we have a biracial baby, their mothers are coming from all over the world, but their fathers are selected from a very narrowly selected ethnic minority group. So how does it happen without this hate content? And how can I track that hate content where some people become the direct target of it? So if you are a machine learning, especially in sociology, and if you want to collect some data analysis, then please let me know, okay? I will be sitting here.
Thank you. All right, continuing. The QR code that you see, it will take you to our AI Camp Slack channel. Please scan and please join. And you can do a community shout out there as well. We have a San Francisco Bay Area channel on Slack. Again, this is the QR code. Please post on LinkedIn. So there is a chance that you could win a nice Bluetooth headphone. I'll give you 10 seconds. It's going. I see more phones scanning. That's great. Awesome. All right. Special thanks to our sponsors, Pulse AI, Aperture Data, and GitHub for this beautiful office. Hope to keep coming here as much as possible. All right. So I think we are ready for our first speaker, Fabian from Pulse AI. Let's give it a shout out. Thank you. Oh,
Good catch.
Let's see. Can you hear me? Check 1, 2. Is that good? Not so good. All right. Louder? Loud and clear? All right. I'll just put it a little bit higher up there. Okay. Hello, everyone. All right. So I'm with Pulse AI, and today I talk about getting unstuck. Basically preventing model lock-in. I think we all know what vendor lock-in is. And I will talk a little bit about that maybe, but like I want to spend the most 30 minutes now about like talking about model lock-in, particularly large language model lock-in. So a little bit about my background. I came from Germany, 10 years here to the Bay Area. I started my first business at the age of 13 in Germany. I built a game server hosting company, grew that company, made it big up to like 30 employees and built data centers. So I built in total like 5 data centers, 3 in Germany, 1 in Lithuania and 1 in the Ukraine, which currently has also 90% of the traffic that goes there through the internet run through us. With building these data centers, there were interesting routing decisions, particularly in game server hosting. All these Counter-Strike players, they really want to have like low latency. And so I was spending a majority of my time also in preventing DDoS attacks and building a sophisticated routing network. And so we built Clayrex, which is the second biggest data exchange in Germany. And when, for instance, Netflix came to Germany and started peering, they peered with us first. So I always had the passion when it comes to routing and finding the fastest path. And also building basically the infrastructure for it. And so that got me then ultimately here to the Bay Area, where I worked at Mesosphere on distributed systems. So we were running supercomputers, if you will, like before Kubernetes, and then Kubernetes on top of Kubernetes as well. And you can think about it, we were taking multiple computers, put them together and made them look like some giant supercomputer. And on top of that, applications like Twitter, Uber, or Airbnb were run. And then as the company pivoted towards Kubernetes, I was open sourcing a low-code operator framework called Kudo, stands for Kubernetes Universal Declarative Operator, which made it as a CNCF sandbox project that made it very easy to build like a Kafka, Flink, or Zookeeper operator in a Kubernetes cluster for your applications. There again, for me, it was also like a big driver was making something that is very complex, super easy to use for your applications, and build on top of that as an abstraction layer these applications. And then I pivoted to Freenome, where I built in biotech basically the machine learning platform. So Freenome does like a little blood test and tells you if you have cancer and what stage of that is, and it's split in the wet lab and the dry lab, and I was in charge for on the dry lab where we ran a lot of like batch jobs to with a lot of like machine learning components to figure out if that is present or not. And then after this, I started Pulse, and so what really is Pulse? In a nutshell, at the core, what Pulse is, we're building a very sophisticated evaluation of these large language models that are black boxes. And with that knowledge, we take it and put it into action. And the first action where we put it into is routing, where we help you to identify for your applications and for that specific request, the best model that we should like route this request to. Large language model, of course. And if you think about that problem space and the space of large language models, it's sort of like exploded over time. The hypothesis that we were building the company on is really that we think that in the future, there will be not like just 5 or 6 of these foundational models, but there will be like millions, if not like billions of customized domain expertise models. And we see that already coming into fruition now with llama models that are like fine-tuned for specific domains and becoming better than like the bigger foundational models and so forth. And we see that also like when it comes to your data, that if you want to run with an open source model or with your data, you probably choose an open source model and run that in your own infrastructure and so forth. So there needs to be, like similar with Google, feel there needs to be something when back in the days homepages came out, suddenly every big company wanted a homepage. Now, like large language models came out, every big company wants a large language model. And what's your Gen AI strategy? There needs to be someone and something that basically ranks these things and shows you which are the best ones, like in a very simple way for your specific prompt. We have that with benchmarks. But it's yet very complicated and mostly also not for like the most tech-savvy person readable and accessible. And so we're trying to solve that problem in a world where there will be millions of these large language models. And so when we're talking about model lock-in, I think we saw this the last couple of weeks, actually, with a lot of activity within OpenAI, but also within Anthropic. I want to pick there on two examples. Let's start with Anthropic. So Anthropic released Claude 2.1. Before that, there was just Claude or Claude 2.0. But similar when you build a Docker container and you just tag that image and call it Docker latest. Then the next time you build this container, it's still Docker latest, but the content has changed. Yeah, and so the same thing happens here when you work with a model like the Claude 2 model. If you were addressing it in your application as Claude-2, from one day to the other, suddenly it's no longer the actually Claude -2.0 model, but it's actually the Claude -2.1 model, which is in some cases entirely different in behavior as the previous model. We saw that with OpenAI as well, with the preview model that they said is called Turbo, but they call it the preview. And so with this one, through distillation, I think that the knowledge that it has and the behavior of the model was also slightly different than the one before. And so this can basically break your application because it's suddenly no longer behaving in the, let's say, probabilistic range that you were thinking it would. In the case for the Claude model, what it does, it is basically less hallucinating. Which is maybe something that you actually want, and that's where your application was built around. For me, for my girls at home, like, hey, come up with a good bedtime story, for instance. If it's suddenly less hallucinating, the stories are less good, and so forth. So who's then in control? Who can control it? Who makes that production ready, and so forth? So that's one thing where you have this model login as well. If you want to switch between these models, even between the same provider. Now let's think about a world where there's another, like a Llama 3 coming out, which is suddenly way better, and you want to try this out with your data, and you want to switch to that model. How can you do that with your application? So it's like backwards compatible, there's not breaking anything, and there's a lot of switching costs involved with that. And then the other example where was with OpenAI, just simple, where when OpenAI was down and your application was built on top of that, suddenly like your live traffic will be down. It's unacceptable for a lot of users. So you would have to implement your entire sort of reconciliation and reconciliation stuff by yourself. And so we can take care for that. And we basically jump to the next best model. There is maybe the next best model for that specific prompt instead of GPT-4. And then there's also these like costs uncertainties that you have. For instance, if you have some power users that burn through a lot of tokens, like Alice in the data science department suddenly decides to like have max tokens set to the 100,000 limit now that Preview so can do, and suddenly this is an explosive cost endeavor for you. So you want to stay in control with this as well. But also costs are like something that are also locking you in, because maybe that's the cheapest model for you right now, but you want to arbitrage it, you want to find another model. And then as a third one, the output of the quality is also something similar to the example with Preview and GPT-4, where the quality suddenly changes, and it's not clear to you how that quality actually started, or like even in Andrew Campacci's last like introduction to LLMs, at the very end he was talking about like the entire internet was scraped in this, and there could be some malicious actors like adding some like little Trojan horse. I think they used it with the James Bond activation, so it's like a sleeper thing. So it's a black box. You don't even know what breaks it. You don't know. You didn't see the training data. So we want to make this a class box, and so not a black box. And that's where I think evaluation and helping you finding out what is really the strength of this particular model, including your fine-tuned models, including the models that basically are tied in with your data. I think that's a number one priority for us. And then ongoing maintenance with coming back to the example with Anthropic. Now you suddenly have to maybe if they actually another better example is OpenAI's breaking changes from having it as from switching from engine to model. So it's no longer an engine, but it's actually a model in the request that you have to call it. So there's like also things that go into like the upkeep and maintaining that. And so there needs to be something that helps you with this. And Pulse AI as a platform is trying to help you solve that problem. And the first really product that we're building is centered around this evaluation. It's centered around that we can dynamically route individual requests to the evaluated, if you will, indexed models that we have. And we dynamically do that also with preferences from the user. So like you can say, based on 3 dimensions, for instance, I have a high preference for being here for the highest quality, cost, or latency. And based on that, the routing decision is different. But that's just one of many. We're working on doing this even like further with task intention based, for instance, that like we know that you have a specific app that is very good with restaurants, and we would just want to like maybe consider models that are very good in that space. So I want to show you actually a quick demo if the demo gods are good to showcase what I just talked about. So I went ahead and just created a GitHub demo application on our platform. You can very easily just with 2 lines of code, like backwards compatible, like integrate that in your application. You just switch the base URL and your token to us. And then from there, you have all of these models currently like considered in that routing decision. Those are models that we index for various problems and evaluated. And so we have AI21 Labs, Aleph Alpha, Anthropic, we have Cohere, we have Mosaic ML, OpenAI, Replicate, and so forth. And we're working on like adding more and more models into that. This evaluation is really expensive, but we also want to like make sure that you can build your own custom models and do that. And so you can select really here, like what is the pool of models that I should integrate with when a request comes in from which I should pick. And then you have other options in your settings, which is sort of the slider where you can select, you have this like preference towards reasoning, speed, or cost savings, and you can enforce policies. Like how often do you want to try it with one model before it hops to the next best model? What's your total token budget or the total budget that you want to have when it comes to this entire request? If you do some RAG pipelines, do you want to optimize that? Because we know that some models are more perceptive for instructions or RAG based on the way how they were trained and also how they evaluated in our building of this sort of knowledge graph. And then also what are your privacy concerns? What logging do you want? You can upload your custom data as a very basic sort of RAG pipeline. And you have a playground that allows you to play around with sort of these settings to see what is the most optimal setting. And then these will show up as a log. And these logs are also like automatically sent to our custom integrations with Grafana and Prometheus and Loki. So you get automatically to your applications like Prometheus metrics, the full observability, you get Loki logs, you can send labels, you can filter it for labels, you can like create alert rules, you get pager duties at night when Alice makes a high token burning and so forth. So I want to show you actually with this application how a request can look like. So this is the very basic app. We just like set it up to use our key and the base URL, and then we send it some labels, and I just call it GitHub demo GitHub 2. And the default label should be all of the quality should be the #1 thing. So everything should be quality in that weight. And then we just ask it the question, I'm bad at math, which is true. What is 1 + 1? And then it's just like spit out that response. The interesting thing is like we consider also models that are not chat completion models, that are not having the chat endpoint, by basically like converting that back and forth in the chat format or in the text format, depending on what you want. So you have actually the entire catalog of models available at your fingertips. So if I would go and make that specific request, let's do this. All right. So what comes in as a return is this known from OpenAI or from other SDKs format, and in that format nothing changes, so it won't change your won't break your application, but we introduce in this format like a metadata field, And within that metadata field, we keep you a little bit of, like meta information about what app was been used, the category that we identified here with our Pulse v0 meta model that we basically built that does that routing decision for you. We show you the cost savings compared to, for instance, GPT-4, how much you have saved because we chose another provider. We show you also like the label metrics that were used, including the latency. You see here quality was set as 1. Here's the latency, then of course the model. We have a fully qualified model path. That means you can, even if you don't want to use our routing feature, you can go and basically like target your model. Like let's say you're using 3.5 turbo. So you can just target that, it won't change. And what you get with that out of the box is basically that observability if you want to. And so you can slowly start switching that in dev and trying out more like transitions over to like the entire routing capabilities. And then we give you also a recommendation engine, like this specific model, and it was the one that we chose for that specific request. But there are other models as well, and every request gets another recommendation, and that's an endpoint that we expose as well. So if before you do your request, you can just send it to that endpoint, and then it says like make this request with, I don't know, like Claude 2 instead of GPT-4, and it will do that for you. We integrate backwards compatible as a normal provider, like OpenAI provider, into every other like framework, like Langchain or Llama Index, so you can use us really out of the box. We integrate with Grafana in their LLM app, so that works all out of the box and is quite pleasant. And so here we see that with the quality one, it shows actually like text Da Vinci, and it cost me like a fraction of the dollar here, and it was like half a second. And the answer that it gave was 1 + 1 is equal to 2. Well, this is great. And then let's say I switch this. Let's say I don't want to do quality, I actually want to do cost. So really what I'm focusing on is like, I just want to get the costs down. So I do the same request, and then I see that actually Mosaic ML, MPT 7 billion instruct was been chosen, and it was taking us more seconds, but it was actually cheaper, and it gave us like a similar sort of answer. So the quality is not that deprecated, but actually the cost is a fraction of the cost, like hundreds of what we saw before. So this is like sort of the arbitrage and the opportunity that you have here by using sort of that technology. And then lastly, if we want to look at just like, hey, I want to have the answer super fast, I don't care about cost or quality, I'll just say latency here, and then we see we have here currently the latency response. And how we do that is we're doing a lot of these requests every second, and we track over time the response time of every model. And based on that, whatever the latest request was with the fastest model, that is the model that's been chosen. And you can also through policies like change that behavior a little bit. And then let's say lastly, what I want to show is let's do this a little bit 50-50. Let's say I have a sort of like preference for cost, but I also have a preference for quality. And so before that, when we chose basically quality, yeah, let's go to quality here back. That was which model did we choose here? That was going to Da Vinci. So now, did I hit save? Yeah. So if I run this again, I see now that GPT 3.5 Turbo was chosen because it was the best, at least in our understanding, the best trade-off with the current knowledge that we had for that specific prompt with the cheapest cost to the highest quality. It took a little bit longer, 1 second, but that was not the criteria, but it was still cheaper than before with 0.0004. All right. Cool. So that's a little bit about like this in action, and that's how you could integrate that in your applications. We provide you also endpoints where you can white label that, so you can like create and update these applications on the fly. I'll just go here real quick and show the logs, because another cool feature there is like when we look at the sort of keys that were there, there was this GitHub 2 key. So you can filter for these specific logs that were just made with that specific label. So you can like think about this. This is my premium users. These are my not premium users. And you can route them differently to different models, or have different even weight policies. Like maybe the premium users have quality always versus the free tier users. They have always cost as the weight to optimize for and so forth. All right. Cool. And so how are we able to do this? And so that is basically through the knowledge graph that we built. And that knowledge graph you can think of is a vector space, a semantic space of these models, where we like send hundreds of thousands of these prompts to each model, and we get like their answers back, and we start rating these answers. And this is based on a few papers. We use rater models, and we're building also our own models for rating. That rating could be, at the moment, this rating is basically like conciseness and so forth. So we prompt it, and then we get an answer for this back. But at the same time, we also rate it for like, is this answer good compared to another answer? So this is sort of ELO ranking, pairwise ranking, if you will. And all this combined basically gives us a very good understanding in what sort of domain and benchmark these models are really good. And we're using our proprietary data set with this. And also, like, you can use, when you build on top of our platform, your own logs, so you can optimize it even further for your application. But we also use a lot of open source data sets, for instance, Harness and Bench and Helm and so forth, that help us to have from various like benchmarks, some like very good prompts that are already rated, maybe, where we know the answer, so we can see if your fine-tuned model is good, or if the new Claude 2.1 is really better than the actual one before, and so forth. And how this looks like is sort of this cloud of prompts, and they have the funny attribute to organize themselves with like similarity. And then when a prompt comes in, we look in this very expensive pre-compute up in milliseconds, and the total overhead is just 15 milliseconds. Like, what is the nearest neighbor to your prompt? And then what model was chosen? What parameters were chosen for this? What was max tokens? What was the creativity and so forth, or temperature for this? And based on that, we make our routing decision for you. If you set these parameters, of course, we override that. You override that. We don't touch it, but if you don't, it's sort of like autopilot basically for large language models, if you will. All right. And so this is sort of the architecture of this evaluation and scoring that we do basically offline. It takes a while to build this, but actually 15 milliseconds is just sort of the overhead that it does when you do it in live production, because we did that. We went through that whole compute for you and provided you this pre-compute. Similar, like how you don't have, when you use a foundational model, have to train it for your single request, but it was already trained, and so you had the final product there. And this is the user prompt comes in. We do our intention-tuned embedding model at the moment that you saw, that is really trained on the intention of the user, which is sort of like the category. But these could be multiple more, depending on the task, depending on what's important to you. And that is then compared in our vector database. And then also could be like filtered even for further parameters. And then we return this back sort of as a recommendation, and then we match it with your users, with the user's preferences, to see what is the model out of the whole like space of models that seem to be a match here. Like if you think about a matchmaker here, we matchmake your prompt with the right model. We don't basically change your prompt. So I think that's something that will be like in the future sort of fade away. And then yeah, we give you the response. And that is built on, like, when you think about answer-based ones, on Big Bench, Evaluation Harness, and Helm, and a bunch more, where we have the prompt and the answer, so we can directly compare it. And then for open-ended questions where we don't have that, including the ones from some users, if they are not yet rated, but we incorporate also human feedback there. But we use this sort of pairwise ranking. There are two good prompts. Which one is better, the left one or the right one? And that's sort of this LLM tournament that we are doing to also come up with a better understanding of like what is the strength of individual models. And for our first iteration of the sort of knowledge graph that we built at Pulse v0, and we're soon releasing the next iteration of this. This is even better. You see already how some of these models are like in different like categories, perform entirely good or entirely bad. And one thing to note there is probably the ones that are poorest performing is currently Goose AI. Back then, Anthropic had a mixed performance, and then Replicate, because they were like, back then there were like a lot of like unreliable issues with their service. It was often down. And then in our new score, all of that has been fixed, and we saw that there was Anthropic with a notable improvement overall. But we also saw that like suddenly another provider became unreliable for whatever reason. And so by knowing this, we know also like where your request should be routed, that you don't run into these issues. And then I think I'm very proud of the partnership that we have with Grafana. When you currently look for LLMs in the Grafana dashboard, sort of like Explorer, we're the only one listed there. We give you basically for free, sort of like high level overview on how your application is doing, like what models have been chosen, what is the cost for each model, what is the cost for each request, for each label, and so forth. So it gives you, particularly when you're in that LGTM stack, sort of the next helper when you have to troubleshoot the applications that you build on large language models. All right, we have actually this Saturday a hackathon coming up. I'm very happy in Cerebral Valley, actually. We're doing with like a couple of I think like 100 folks or so, like are coming. It's a very curated guest list where we're working on some very cool examples on how this can be used. So if you want to stop by, please just like sign up there. Happy to push you further there in the waiting list. And then we also have our community in Slack where you can join and ask us questions, and we're very fast. We actually built the company with 2 hubs. We have one hub in Europe and the other hub here in the Bay Area. And what that enables us is basically have these 24/7 cycles when there's a request in the Bay Area, and then the team in Germany and Europe and Switzerland and in the Ukraine is working on it. And then by the time you wake up, your problem was fixed. And then please sign up with Pulse. We also give away like a exclusive coupon where you get $1,000 in credits that you can spend on it. Just like reach out in the community. Happy to make that happen. And yeah, with that, I think I want to open it up for questions. Thank you.
We have the first question here.
That was awesome. First question is, how big can the graph get before you need to prune it so that it's still responsive to you?
Yeah, so like at the moment that the size of the graph is really like, it's dependent, and when you think about cardinality and so forth, it's dependent really on the number of models that are currently there. I think we don't have yet the number of billion models, but this is really an issue. So the graph can go without a problem of performance issues up in the hundreds of millions.
Because I thought you also keep track of the prompts coming in because you want to do a similarity between those. So that could get interesting.
Yeah, so when we talk about the prompts, we basically like do that the entire compute that is compressed into the graph, basically like before that, and it's not happening in real time at inference. And so that allows us that even if this prompt space starts, we can do that even if it takes let's say a month to compute this, compress this down into like a very like efficient lookup in that database. And we're very agnostic. Coming back to the point of we want to provide model lock-in, it would be, I think, like ironic if we would have ourselves suddenly a model lock-in. So for that, we're agnostic to any vector database that like supports sort of that. No.
Last question, and then I'll give the mic up. At an enterprise, I'm assuming this is going to be run for that enterprise, for that customer, which means the model grows as the enterprise uses it. So part A is, do you start with some knowledge from other experiments you've done so they have a starting point, and then as it grows for that enterprise, I'm assuming it stays local and private to that enterprise?
So there are like multiple aspects to this. All of this is running in a Kubernetes cluster as a Helm chart. So we could deploy this like for like these enterprise customers, and we're working with a few of them already in their projects, in their environment, where they actually can customize the entire thing to their need, and it's just like very isolated and air-gapped. You can decide what models you want to choose. We're also working on the sort of fine-tuning part and the inference part for open source models. So for instance, like let's say if you do that and you're air gapped, and we're working with Unity Defense Unicorns actually on their integration, where this is deployed on submarines, and they want to really see like the manual of like thousands of pages. And so there you don't have a reliable internet. And so which model you can go to GPT-4, that's not available. And so what comes with us, we're building on open source. Everything is on open source that we build on, and that is Flight and Ray. In particular, Ray Surf is very helpful when we want to have these open source models run. And then of course, which of these need to be addressed. And so you can do that all in your own project, totally air gapped, if you will. Yeah.
Thank you.
Any other questions?
Fabian. So my question is, do you let the users or your customers to provide the performance tests, or you have like a battery or test regarding you want to test mathematical abilities or some language abilities or some specific knowledge? How do you handle that?
Yeah, so that's actually a great point. So we're working on a tool that like the main idea really is that with that evaluation, we sort of get a very good idea of like which model is currently the best one, and we want to give that back to the community. So we're like releasing on our blog sort of these stats, and we want to also do that monthly when there are new models coming out, or if we add new models to our platform, show the strengths and weaknesses of these models. And those are public available data points that we want to give back. And then also at the same time, the data set that we've been using to evaluate this is also very interesting, and we're thinking of open sourcing that as well as time progresses. Yeah.
We have time for 2 more questions. Anyone? Oh.
Hi. So I'm working on a product on an autonomous agent that does prompts, and it does sequences of prompts. And only at the end of the sequence do I know if all of the prompts were good or not.
Yeah.
Are you thinking of grouping prompts together and then having a single value at the end?
Yeah.
Be useful for us.
Yeah, so that's a great question. And so like since we're like so agnostic, you can use us with like Llama Index, Langchain, or with your own proprietary one, as long as it integrates with one of the big players, SDKs and providers. We're just a provider there as well. And with that, for instance, RAG is a good example. With Llama Index, how we do it even internally, we give you that sort of like tracing, like open tracing, if you will, or distributed tracing. And there are some other tools from Langchain, like Langsmith and so forth, that allow you to do this a little bit. But we allow you to do that as well on our platform, because it's basically a platform is like not just, it makes like multiple features make it a platform and not just a routing part. And so, yeah, we allow you to do that. We allow you to also like trace it based on the labels. That's another thing. I think with our open source partnership with Grafana, the next integration that we're actually working on is with Tempo and a bunch of other tools that they have to allow for these tracing capabilities, particularly when it's about a large language model application. And so you can see how in your system these requests went through. For instance, with Llama Index, what we have is we have like these extract requests that happen 5, 6 at a time. And then there's this entire final prompt with the high level sort of like answer that you were actually looking for. And if your support team has to troubleshoot how did it came up with that answer, or what went wrong at step 13 or request 13, that is very easily by just us being in the middle of this and being able to facilitate that for you and visualize it for you. Yeah.
Last question.
In the context of AI agents, what kind of formalization of like all the AI agents, especially when it comes to other kind of structure? So what kind of formalization do you do, and what kind of how do you see these AI agents working together?
Yeah, so like a good example would be, I think the latest Open Orca. What was that? I think Mistral 7B Open Orca. So wait, let me check real quick. Here, yeah, Mistral 7B Open Orca. So depending on how it was trained, it used the different sort of like special tokens that it had. And so like you cannot just like write and address it. It needs to follow a specific format, which is different than the format that, for instance, GPT-4 would expect and so forth. And so what we do is, that goes back to what I mentioned with the difference between the chat and the text completion endpoint. We also allow you to basically translate that for you and convert that for you if you want. So how it's implemented right now is we just detect if these special tokens were given by you, and so we don't do it, and we think that we keep it as raw. But if they are not, and it's just what color is the sky as a question, we bring it into the format, and that just sort of that prompt formatting like makes it better. But that's the only extent how we change it, just so the formats are actually matching. And with that, you basically don't. It's again the load of you is off. You don't have to do this. Yeah, and yeah.
that for my intention? Like how like
yeah, so we try to like it's really hard like to come up with a standard sort of like industry standard with these sort of things, and I think the industry standard is de facto like the T-Rex like OpenAI and whatever they give as a response. And so we're very close to that like standard because everyone is sort of integrating with them, and we're just enhancing that. And so that's the standard that we're trying to like start building. The interesting thing is, for instance, also when you think about fine tuning, what sort of standard you have, like you have these JSON line files, for instance, and what do they follow? And so what we do is as soon as we like make it in a uniform format within our our platform, similar how Salesforce does that as well. And that's why we're so great with switching towards AI, because everything was in the uniform standard, and so they don't have this like nightmare of like, oh, the standard is different. How do we convert it? So that's what we do when we use our platform. That's also what you get, and that's also preventing you actually from the model login, because if a new product and feature comes out that would expect that new format, we're doing that for you under the fly, so you under the back, so you don't have to do it.
Awesome, thank you, Fabian.
Thank you.
You can leave the wire down, it's fine. All right, next up we have Apoorva Jaiswal from JP Morgan. Let's give it a round of applause.
I hope I'm audible. Okay. So hello, everyone. My name is Apoorva, and I'm an applied ML engineer at JP Morgan Chase. So the topic for today's talk that I've picked up is Introduction to LLMs and Langchain. And as we also saw in the previous talk that was going on around LLMs, Langchains, all these terms are becoming very ubiquitous around the area. And, it's a very usual norm nowadays for everybody to talk about LLMs. But then when you go ahead and talk to some people about it, like people who are maybe designers, right? Maybe people who are working in UX, maybe people who are in gaming and things like that, they probably do not really understand what's happening inside the LLMs, right? So one day I was having this conversation with some designers from my team, and they went about and asked me, we want to use LLMs, but what do they exactly do, right? What's happening with it? And like, how is things working inside it? So this is going to be probably an attempt to understand from the very basic of what are language models, and we'll go through with it, and eventually at the end we'll try to see how do you build applications actually trying to use these. So that's the whole idea of AI, right? Making our lives easier. So how can you go ahead and eventually pick up these tools and the various kinds of models that have come up, and then eventually build something which is going to help you, right? So first things first, what are language models? So in very simple terms, it's a neural language model, a neural network, which eventually is supposed to give you the output of a word given a particular prefix. So if you go ahead and feed something like students open there, this kind of input, it's supposed to output books, because that's most probable next word probably for you, right? So that's what, in a sense, language models do. Now, how do they work? They go ahead and try to calculate the probability distribution over the whole vocabulary. So let's say you have a vocabulary of English, for example, you would have thousands of millions of words over there. And then what happens is that given a certain kind of prefix, our brains actually try to identify what is the next possible word. And that's exactly what happens inside these models as well. So given a word, which has to be predicted, you have to always go about with the prefix. So students open there is the vector that has to be calculated for that. And based on the vector for that, you would go ahead and use the probability over the whole vocabulary and come up with the next word. So let's say in this case, books and laptops are two such words which are kind of probable, but books has the highest probability, so maybe that gets selected. There are different ways of selecting which is going to be your next word, but let's say you want to select the most probable one, and that's why you would go ahead and pick books. Now, on the bottom section of this slide, we also have something called low dimensional representation of students open there. What does that mean and why is that essential, right? So computers understand math, as we know, right? They understand numbers. So what happens is computers would not really understand what is students open there. That's a language of humans. Specifically in English language, that is the term. But if you go ahead into a different language, probably you would also not understand what it's trying to say. So that's why it's important to have a low dimensional representation of a prefix or a sentence to go in there, and that's what is going to come up with. And the whole reason of identifying this previous or prefix set of words that were used to identify the next word is because computers do not understand the difference between foot and foot, as we can see on this diagram, right? It understands that only when it understands the context. And that's why the context, essentially the previous prefix that we were looking at, is essential for predicting the next word. So that's all that's happening inside language models in very simple words, right? It's all it's doing is trying to generate certain amount of text. Now, how did we go from the whole ChatGPT boom, right? Like, I don't think it's new for everybody to know the word language models, but it definitely is new for people to understand what is large language models and how did that become a household term, right? So initially as well, since a long, long time, we have had language models which are supposed to take a certain input and give a certain output. But then the problem with them to be used as a dialogue model was the alignment problem. So for example, if the user gives input something like explain how the bubble sort algorithm works, it can give the output as model explain the merge sort algorithm works, because this is semantically similar if we understand the meaning of these two questions, right? So it's not actually supposed to answer questions. That's not what language models were designed for, right? But now what we were trying to do is, can we go ahead and have a dialogue with these models, right? And in that case, you also need the capabilities in these models to understand the text that you are saying, not just in the terms of it being a text, but it being a question to you, for which you require to give an answer which is going to be human satisfactory. And in March of 2022 came something called Instruct GPT. With this, the capabilities of understanding the prompts and giving a response which is more probable for a human to accept was what came into picture. So say if there is a question like explain what is meant by time complexity, and you give a reference answer, and then you ask the question, explain how the bubble sort algorithm works, there's a high probability that this is going to give you the answer that you're expecting, because in this case, it got the ability to follow the instructions. So from the question and the answer over here, the models could understand that I need to actually understand the question and follow the instruction that has been asked to me. So not just say what has to be the next most probable word, but rather also answer it in a way that is going to be understandable for the human. And then in November 2022, exactly 1 year ago from today, came ChatGPT. So with this kind of model came in the capability of not just understanding the prompt and giving the answer or following the instruction, but also giving the answer which is more probable for a human to like. So the technique that was used here along with the instruction following was called RLHF, specifically reinforcement learning with human feedback. So a lot of people have this idea that, a lot of humans were required to do this. So a lot of prompts were written, a lot of answers were written. Along with that, what was also written was how probable is the answer for you. So if, let's say, the prompt is given to a language model, and if an answer is generated on a score of, let's say, 0 to 5, on a scale of 0 to 5, how probable is a particular answer for you, right? And with that feedback, when going back into the system, these models learned how to give an answer which is also very probabilistic in the way that the users would also like to see this answer. So that's how came the ability in these models to not just follow the instructions, but also make it more human-like, something that the human is more likely to like on a scale of 0 to 5 or 0 to 10 or whatever was the scale used in that case. So that's how exactly we went from having language models to models that could understand instructions, and then eventually models that could understand instruction, have a dialogue with you, but also make the response more human-like. So this is how a basic OpenAI's dashboard looks like. You have something called prompt, which is what we've been talking about. Prompt is nothing but the question that you're going to pose to these language models. And then comes the response from it. So for example, in this, the question was name a cuisine that is vegan friendly, right? And it came up with an answer that probably Indian cuisine is vegan friendly. And the next question here was name another one. Now, the observation is that because the question was name another one and not exactly describing what is being asked, the dialogue that was happening over here actually kept the constant, the context that was maintained. And with that came the answer of Mediterranean cuisine, which was another probable vegan friendly cuisine, right? So this is the power that was brought in by RLHF and Instruct GPT-like performances combined together. And that's why these models are more likable by humans. Now that we understand what is a prompt is basically a question that you would ask to the language models. There are different techniques of prompting. And as we understand, these models are black box. The only way of us communicating with these models is through these prompts. So it's very important for us to come up with prompts that these models understand the best and are also able to give you an answer which is satisfactory. So one technique of prompting is called zero-shot prompting, which is essentially you just asking the question without giving it any kind of example of what you're looking for. So for example, here, classify the text into neutral, negative, and positive. And all you're saying is that this is the text and I want to know the sentiment of this. And it comes up with the answer that, the sentiment of this text is neutral. Now, the next most important way is few-shot prompting, where you go ahead and also supply it some sort of examples. So think of it as a small kid whom you're trying to teach a math problem, right? So if you go ahead and tell the kid that just solve this problem for me, that's basically a zero-shot prompting. But if you go ahead and teach the kid how exactly to do a similar kind of problem and then expect an answer, there's a higher probability of them being able to solve the problem better for you, right? And that's exactly what few-shot prompting does. You go ahead, provide it a sample example. Like in this case, it was, I think The Intern is a good movie, but it has the potential to be better. Sentiment is neutral. And this time when you ask the question, it's also able to tell you the same response. But if you go ahead into a more complex question, it might be able to give you a better answer just because now it understands. This technique is seen to be very useful in practice when we go ahead and try to solve math with LLMs. LLMs are supposed to be not that great with math if you have ever actually tried to run some math problems with them. But if you go ahead and provide some examples like this, it actually does a pretty good job. And that's where this comes into picture. Now that we understand the idea of how LLMs work, the idea that you can go ahead and use few-shot prompting, maybe zero-shot prompting, and how do they actually come up with results which are helpful, how can you go ahead and use them to increase your productivity? One way is probably to go ahead and use something like Langchain, right? And build applications out of it. Now, you must have seen all these applications coming in the market where people are using different kinds of vector stores and helping you fetch results from there very fast. In fact, a very new way that people are trying to use this is vector stores. So there are stores where people are using their embeddings, the text embeddings that are created, the same low-dimensional representations that we talked about are being stored, and it's very easy for us to then fetch something which is much more similar to it. So what Langchain does is that it comes up as a wrapper on top of basically everything that can be done with LLMs. So it helps you use vector stores, prompts, agents, chains, LLMs, document loaders, and much more to combine everything together and help you build a whole application end to end. So we'll go ahead and see some parts of Langchain, what it provides, and try to solve a sample use case. So let's say your prompt is, tell me about the revenue forecast for 2023 for the retail sector, right? If this is the kind of question that you have, you might or might not be able to get this answer from ChatGPT. One, because it might not be trained on the data for helping you with the revenue forecasts and things like that. These kind of data are generally proprietary or third party, generally available through you going and purchasing them. So this kind of data is not available freely for models like ChatGPT or any other model for that matter. And this is where you would want to plug in your own database, your own store of knowledge. And that's where specifically Langchain and other such frameworks can come and help you. Build an application which will still let you answer the same question, but using your own database, your own knowledge. So a very common word that we've been also listening in this boom of ChatGPT and LLMs is hallucinations, right? So we know that LLMs go and hallucinate. The primary reason is because they do not know the answer. It's just like, when you go on an interview and maybe you do not know the answer, but you're trying to reach there, so you would probably end up doing that. That's what humans do, and that's what machines are doing, and that's literally what hallucination is, right? So what we are trying to do is give it the correct information so that it's not going to hallucinate, right? If it knows the correct information, it's going to give you the right answer. With that, now that you'll be able to plug in some sort of information which is actually revenue forecast related, you might be able to come up with an answer which is actually going to be correct. And this can be done by using Langchain-based applications. So this is a snapshot I picked up from the Streamlit. So for people who do not know, Streamlit actually lets you build the UI using Python, and it's very easy to use. So with like few lines of code, you're not writing any more HTML, CSS, JavaScript, any of those things, and you can just have a simple web app come up into the picture. So that's the front end, which is Streamlit. But the backend is still going to be your Langchain-based application. So let's say you have in this image, we have this section which talks about the modules that are available within Langchain. So we have prompt templates which help you decide the right prompt for the kind of question that you're looking for or the kind of application you're trying to solve. The memory. You can also go ahead and provide your own memory, your own databases, your own indexes for that matter. Sometimes you also want these agents to go ahead and make continuous calls because sometimes the answer is not just one call away. Maybe you need multiple sets of reasoning to reach the answer. So that's what is something that agents do. And then with all of these modules into place, Langchain is giving you a capability of using these modules along with the LLM framework. So let's say you want to use OpenAI's models or maybe OpenLlama or any other model for that sort. It will go ahead and interact with that and come up with an answer. And with that, if you go ahead and try to use Streamlit-based application, there you go. You have a whole end-to-end application ready. So from us, like 5 to 6 years ago, us writing JavaScript, HTML, all of that, maybe using Streamlit as well for the front end, to now actually just using these agents, which can be used along with the models that are available, the open AI models, maybe you can go ahead and build a whole application end to end in like few days at max, right? So first things first, the input and output that can be used in these modules, right? So the first thing is the prompt, as we understand. So in here, we know that there has to be a particular format of the prompt because it's very important for it to understand the right format. So let's say you want to go ahead and have a format like does X like Y and Y. This lets you define a format and not have, hard-coded values in there. And then you can go ahead and fetch values from different sources, maybe based on the user selection and things like that, and plug it in. And once this has been created, this is what your prompt would be. And this would eventually go into your LLM or chat models and would give you the answer, which has been predicted. And then you can also go ahead and add something called an output parser. So now you can control the kind of output that's coming out of this. And with that, you will be getting the complete input and output through the Langchain. Now let's look at some example prompt templates. So this is a snippet taken from the Langchain's documentation, which tells you exactly how to do this. So if you go ahead and provide the same kind of prompt example and say that I want the adjective to be a variable and content to be a variable, and then you go ahead and try to ask it to generate something, it would be able to plug in these values and come up with its own prompt. So think of it in this way, that let's say you want to have a particular format, but then you also want to go ahead and plug different values. And that's where this would come into picture. Now, how do you select these examples, right? So few-shot prompting helps, as we understood. So it's always good to have certain kinds of example selectors. So one way is length-based example selector. Let's say you want to identify only examples which are of a particular length. So let's say here we have given the length of 25, and maybe you'll go ahead and pick only 25 length examples and plug it in there, and that's it. Second kind is semantic similarity-based examples, which is very popular. So let's say you want to have a question about animals. Maybe the next time you want to have a question about animal kingdom. All semantically similar. Maybe next time you want to go ahead with plant kingdom, right? So all of these can be plugged in, and from your database, you'll be able to select different kinds of example and plug it in. Then comes max marginal relevance examples. So you do not want to have a lot of difference, but then you want to have examples which are also in the range, which is, what you want. So not just semantically similar, also similar in a way which is also different. So you're not always looking for, different kinds of examples, but also a diversity of them. So that's what max marginal relevance brings. This is a custom example selector. So this, using something like this, you would be able to add your own examples and select your examples. Now, another important part of the whole Langchain premise, which is language models. So without them, we won't be able to use a lot of it, right? Next, chains. So chains are very important for us to go and plug together now the LLMs and prompts. So you got the prompt ready to go and you have your LLM. If you pull them both together into a LLM chain, that's it. So you have a kind of prompt and you have a model which is going to answer the question for you. Now, what happens if you want something which is helping you to do the decisioning, right? So let's say if you come up with a math problem, chains might not be your best bet. Something like agents might be your best bet because these would help you reach with different kinds of decisions. And we'll see an example towards the end where I'll show you something where the LLM actually fails, but then reasons itself out of it using agents. So I will now go ahead and show the example that I was talking about. So I went ahead and created this simple application over here, which is a Streamlit app, and I have actually plugged in different kinds of tools over here. So one tool is a pandas tool, and then another tool is a tool which just does a question answering on top of this blog. So I picked up a blog, and it's a web-based browser, scraper like Beautiful Soup or something, and it goes ahead and gets the questions from there, and you'll be able to ask it the answers. So in here is the code that I wrote. So first things first, the LLM that was designed, and then with that, I went ahead and created this web-based loader, which is actually reading out this blog. With that, I tried to include both of these tools into a single tool. And then with that tool, I'm calling this agent as I described. Once the agent has been described, you'll see that I'm only giving it an input text. And it's this whole tool set that's going to decide which one of these tools is the best to give me the answer. Nobody is going to tell it that. So if I ask it a question like this, write code to generate one hot encoding for a given text. Now generate one hot encoding for this. You can see that it actually went ahead and generated the code and also generated the answer for us. And I also want to come up with another question over here, which was in the blog. So what is the architecture of reflection? So this right here is a part of the blog. It's a technique which is used to equip the agents with dynamic memory, as we spoke about how agents can use different kinds of memory. So in here, if I go and type this question now, so this time, as we can see, it's making the decision of choosing which tool is the best for it. Now you can take this idea and extend it further. Let's say you have a knowledge graph database. Let's say you have a SQL database. Let's say you also have certain PDFs. Let's say you have CSVs. Let's say you also have, all sorts of web-based tools. Maybe you want to scrape Wikipedia. You can come up with a single initialized tool set, which is going to be plugged into your agent, where you will initialize all kinds of tools. And all you will be giving your user is something like this, where they go and ask the question. And based on the type of the question, it will figure out which store to go and fetch the answer from. And now that we see how it's able to give the answer, let's also take a quick look at how it decides that. So all the magic happens over here. So in the tool section where we describe that, there is a text QA system tool where I'm using this retrieval agent, I gave it a simple description that whenever you're asked questions about LLM-powered autonomous agents, this is your go-to place. And whenever you ask questions to generate, Python code for a problem, this is your correct tool. So that's how you give it the whole toolbox, and then it itself decides, which tool is the best, and then goes about it. So that's pretty much about how LLMs work and how you can use Langchains to come up with simple applications. Thank you.
Thank you, Apoorva. We have one question slot. And after the talk, you can, of course, towards the end, you can ask more questions if you have. Any questions? All right. Okay. Thank you, Apoorva. Thanks. Next up, we have Vishakha Gupta from Aperture Data.
So I wanted to start by thanking AI Camp and the volunteers here for inviting us and for all of you making time on an evening to sit and listen to so much about language models and vector databases. I figured since vector database is everybody's favorite topic, whose isn't? Who doesn't like vector databases at this point? You wish you had never known about them, but there's no escaping anymore. But what I want to do today is to focus on what comes, not just the vector database part. We got a really good insight into how vector stores get used in the previous talk, how you can tune different models in the talk before. But I want to talk about things from the data perspective. That is one thing that in the early stages, people forget how much impact data has and what comes before and after and during the whole, when they're talking about vector databases. So that's the perspective I'm going to take in this talk. Let's see if this works. I did turn it off again. So just to set some fundamental terms, as you all might already know, multimodal AI, the simplest example of this is how autonomous cars combine different modalities of data. So they are using their cameras. Some companies use LiDAR, there are audio sensors, and all of those things combined go into these models to get you where the car is going and a depth perception, so they hopefully do not hit anything. Which brings us to multimodal data. Essentially, it's just the place where we have been most accustomed to multimodal data is doctors. They use CT scans, X-rays, their own notes, blood tests, all sorts of tests that you can think of in order to diagnose patients and maybe come up with a treatment plan. And so multimodal data here essentially refers to different types of data that we end up using. Now, and it's not just in doctors' offices. You can combine video with audio. You can combine text with images and learn a lot more. Essentially, one type of data gives you one information. So for example, since I just flew back from Vegas this morning, if you're monitoring the surveillance, the casino floor, if you're just looking at the video, people might seem like, okay, well, everything is going fine. But if you start listening to audio, maybe somebody is counting numbers and helping them win. Just one example of how you could combine the different modalities of data. So then, where do embeddings come into picture? Why do we make a jump into that? Well, think about what we end up doing with this data. All of these things we are doing, all of these things we are talking about, is because we want to search through the vast collection of information we have, and we want to find something we are looking for. Either we are looking for some information that we forgot, something we want to learn, or something to drive future outcomes, either better outcomes for our customers or better outcomes for our employees and the company. So really what embeddings help us do is think about how large your images, videos, audio, all these complicated unstructured data types can get. So to look through all of them, if you had to compare pixel by pixel to find my face in a gazillion number of faces, that would take us forever, and it's not the most efficient. But that's where embeddings, as she explained, help us give this lower dimensional representation so that it starts to make it faster and easier for us to spot what we are looking for, at least get approximate answers, and then we can get to the more specific answers. So that's really just very fundamental way in which I think about embeddings. And typically what ends up happening to extract these, you have different models that you put your data through, and you end up using the penultimate layer of the model to represent your embedding. They used to be configured by hand first, but now you basically rely on the models. So what do you do with these? Well, by nature of what they represent, the most common use of embeddings in, we have focused classically in our company on computer vision data. So I'll give you an example from that. In the visual space is to find similar images. And when do you find similar images? Let's say you're an e-commerce company and you want to recommend products to people. You want to recommend them products that they're more likely to buy. Or let's say you are a retailer and you want to find, what is this product I'm looking at? Is it supposed to be here? So that's a classic compliance problem that they have. And then you can have embeddings that actually represent different modalities. You can combine text and image. And then I'll show an example with the demo when we get to it. And that, the operation of finding similar data leads to a few complex requirements. So just because they are fewer, lower dimensional representation doesn't mean the problems are easy to solve, which is what leads us to the special support creating the need for vector databases. As a data science or an entire team uses their well-trained models to extract embeddings, they need a location to efficiently index these embeddings. If you remember from database concepts, anytime you want to search something fast, you have to build an index on it. Typically, in the classic database world, you build index on one attribute. Here, you're talking about multiple numbers that will help you find what you're looking for, and so you have to build high-dimensional indexes here. So that's the indexing part that a vector database needs to do. Then another case is I have an example embedding, and I want to know what the label of this is. So I give it the embedding, and it tells me, oh, this is the picture of Michelle Obama. That's classification. And then the third thing the vector database needs to support is finding similar looking items. So you give a picture of Taylor Swift, and it shows you pictures of other people who look like Taylor Swift, hopefully some of our own pictures too, if the model is trained well. So, so these are all the use cases that vector databases have to support. If we're talking about industry examples, I already mentioned e-commerce and retail. There's also growing use cases around defect detection, visual inspection. People want to figure out if some product is defective by just looking at the picture and finding if it matches some defective product so that they can avoid a failure in the future that can cost them millions of dollars. So, because these are hard problems, but very, very valuable, as we can imagine, and you guessed it, with vector databases, you can solve this. And now there are so many choices in the market. There are specialized vector databases, and then there are existing database vendors who are adding vector types, because why not? It's numbers after all. And so how do you choose? When you're building your application, how do you choose amongst these? That comes down to your specific application. Are you okay with the cloud-hosted solution, or does your enterprise need something hosted in their own VPC? What are your cost constraints? How much do you want to scale? How much do you want to pay? So there are a lot of these things that you have to evaluate with. But there is something else I want to highlight here. So through a lot of our user interactions, and we have been looking at machine learning using complex data for quite some time as part of our work at Aperture Data, and before that at Intel Labs. And what we have learned is that a lot of these vector databases, any of these could be used for some of the use cases I've mentioned so far. And while they solve a very important problem, they don't solve the entire problem. What they help you do is when you have the embedding, or maybe some of them help you extract embeddings, they'll help you find similar items. But there is a lot that happens before in terms of data collection, training your models, and then a lot that happens after. It's not just vector searches, and I'll give you examples of what other things that you have to take into account when you're deploying a real application in the industry and not just evaluating these things. So let's take some examples to build our mental model. A very simple example is finding faces in a collection of faces. This could be for surveillance. It could be for finding where did you see a particular actor, which actress, which movie did she act in? Any of these things. So maybe the first thing you want to do is just find by similarity. But then you want to constrain your search and say, well, I want to find this similar face, but I also think that I remember this person having dark brown hair. So the person I'm looking for looks like this person, but they also have dark brown hair. So that's, now you have introduced a metadata attribute in case you see the progression of these queries. And let's say you are looking at celebrity faces. You put all that constraint, and now you want to say, oh, and I also remember they acted in ABC movies. So if you see this evolution, we started with similarity search, which a vector database could help you do. But we very quickly evolved into more and more complex metadata filtering. Similarly, there's another application we've been running into in terms of chat support, thanks to all the capabilities that LLM and what we heard in the previous talk, they provide us to do. It starts out with like, let's say it's a company that sells some large number of equipments, millions of equipment. So there are tens of millions of manuals associated with them. Some user sees an error code and they want to know what it is and how to solve it. So the very first question is, what does this error code mean? You can ask this to a ChatGPT-like bot built for that company. But then you want to ask, I want the answer for equipment built between 2022 and 2023. So there you've introduced more metadata filtering. And now you also want the manual. So not only you want the computed answer to your question, you also want to see the original manual. So again, that's what we've done. We have added complex metadata filtering on top of similarity search. So these were some examples that we've come across, but I also wanted to use some examples that we have been building with our customers. And this is where it gets into, we have more insights into their pipeline. So I can add what comes before and after in these cases. So in case of this home improvement retailer, it's an e-commerce use case. They want to do visual recommendation based on colors and shapes of the product, but they also want to make sure it is from their fall 2023 catalog or from a specific merchant. So we have come to you want to find by similarity, constrain by metadata, and then return images. So before they can execute those queries, they have to create and manage data sets easily and be able to evolve them because their catalog keeps updating. Then they want to be able to train models iteratively with millions of images. They want to index embeddings. And that's when the vector database part comes in. So as you can see, there were all these steps that involve millions of images and a lot of data moving around and a lot of concepts around it. You're training with that data, you are managing data sets, maybe you're versioning your data sets. I'll take another example. Here, this is that robot that walks grocery store aisles. If you're from the East Coast, you might have seen this one. What they do is high throughput vector search. They take pictures, convert them to embeddings, and then send that for a product lookup at scale. And these guys too, before they could execute those queries, they had to create and manage labeled data sets. So they had to work with the labeling framework to label the products they were seeing, and then train models, again, millions of images, and index embeddings. So if I were to summarize, and I've taken 4 or 5 different use cases to give you a variety and a perspective from different verticals, if I were to summarize the common expectations or requirements, you typically want to index and search over high dimensional embeddings from different types of data. And you want to allow metadata-based filtering and retrieval of the corresponding data after the search. So you're not just stopping at finding, okay, well, this is the URL, you want to return the data too. And so the requirements, if we look at it, you want to support high throughput vector search and classification. You want to filter on rich and ever evolving metadata. These applications evolve so fast, you cannot define a static schema and be happy with it forever. You'll be changing it every few months. And if you have IT systems that are old, you will be fighting with a lot of people about changing the schemas. And then you want to be able to connect with your original data and fetch it easily. Again, if you have permission systems that restrict you from going to S3 buckets or your GCS buckets, good luck with that. Then, of course, all of this stuff as soon as you go beyond R&D, you're going to be deploying in production. You need that system to be reliable. You need all these machine learning systems that rely on the data layer that you're building to be scalable. And the enterprise ready, which means all these encrypted communication and the ability to log and monitor and access control, all those things come into picture. You don't want to be tied to a cloud vendor. You very likely want to deploy it in your VPCs. And that's where we feel like a lot of the vector databases that we look at, very frequently they store the feature vector, index it, and they return you an ID, and then you have to carry that ID around and correlate it with the different data types. Lately, you can attach columns. You can maybe put some metadata information. And then rarely, there are complex schemas that you can overlay so that you can, and a lot of these applications, if you look in detail, they are very connected applications, which means they map better to graph models, which is why I'm saying that. Rarely, there are a few vector databases that support that sort of complex filtering. And then, not to mention all the choices we talked about earlier, SaaS versus scalability versus enterprise support and things like that. And they are very frequently missing the ability to support the actual multimodal data types themselves. So knowing what that leads to, and okay, we understand that they are not sufficient. So what's the problem? They are not sufficient. We'll plug in a bunch of different tools that we know of. So let's try to do that. Let's walk through that example. You get all this data. That's the output you want to get to. So you ingest the data. You put the images, videos, documents, everything into buckets or file systems. You take the metadata, map it to whichever database you know best. Then sometimes you have to label data. You bring in labeling frameworks, take the labels, and now you got to ingest them somewhere. People literally dump them in cloud buckets, and then they pass buckets around. We've seen that happen. I've actually come across someone dealing with terabytes of data with metadata in Excel files. I kid you not. And then you query, then each person is writing their own flavor of scripts to query information from these variety of tools. If you're dealing with things like images and videos or maybe audio, you have to bring in all these complex processing libraries so that you can process your data into the form factor you need, because very often your models cannot take the original resolution and original form factor. So you have to redo that formatting or create copies. And then finally, somewhere you put that vector database as one of the pieces of this infrastructure puzzle. So ultimately you land with this spaghetti of an infrastructure, which you will have to build, maintain, and debug. Mind you, as soon as your models start to get complicated, you're going to have to debug this part. And so that very easily ends up taking a very long time to build. And it takes a lot of people to build it and maintain it. Now, of course, I was building all of this to kind of advertise our product. I wasn't going to not mention that. So the one thing what we realized after doing all this, like looking at all these examples, is we needed something that would understand the complexity of multimodal data, but also provide an interface thinking from the perspective of data science and ML engineers. They are the ones who are responsible now to tune the models to get more insights from the data. So what we built into ApertureDB was native support for complex data. In fact, for images and videos, we've gone ahead and implemented some pre-processing functions. So you can request samplings of videos or resize images directly through our query API. And then metadata is a very key part, as we saw in a lot of these examples. And it needs to be something that's rich. So we have an in-memory knowledge graph within ApertureDB, which connects everything together. And then vector search is a very essential way to find your data. You want to be able to find by similarity. So that's a third way to look. Third way. The second one that I missed is if you have labels, you can search by labels, and they're part of the graph metadata. And so now all of these things are connected together, and we built a query layer or an orchestrator on top of all this so that users are no longer talking to individual systems. We take care of redirecting the queries to the right components, enabling a transactional layer so that if you are adding an image with embeddings from different models, all of them can be added as a transaction. You're not adding one embedding and then something fails and you have like one embedding floating around without the image corresponding to it. And then all these, the users, the machine learning pipelines can talk to the database, they can add, query, remove data and metadata, annotations, feature vectors, all of those can go in the same system. And you can do on-the-fly visual pre-processing. You can do more ML tasks like creating data snapshots. So that's really what ApertureDB does. And because it's purpose-built for these kind of applications, it can really address a lot of the data management and multimodal data challenges. I'm going to skip this in case you're interested in where ApertureDB fits in all this. There's, of course, enterprise support. There's all these client systems, and you can read all that. I'll share the documentation. But the key part here is when you do your data right, you cut down a significant chunk of time you were spending just manipulating data into the right shape. And so in case of the examples we were talking about, at least with our customers, there were things that they used to take days or hours, which have been now brought down to minutes. We just had a case study come out in terms of how the retail customer is scaling there with our very fast vector search capabilities. And what I wanted to do now is just quickly show you an example of what that might look like. So if you go on our documentation page, you can, wait, I am not showing my documentation page, is it? All right. So here, essentially like any database, we have objects. And in our case, the special objects, we think in terms of entities and relationships instead of columns and columns and rows. And you have connections between these, and each one of these can have attributes. And then you have add, find, update, delete calls. That's essentially what you're doing. And so if I were to just quickly show you an example of doing a similarity search. Well, we talked about pizza a lot. So let's take this image of person eating pizza, and with our Python API, you can literally run, of course, anytime you try to run a demo live, something goes wrong. So this is the part where we have different wrappers in our library, and you can literally just say these embeddings were already indexed. You can say I want 15 closest neighbors. I'll go ahead and show you pictures of different pizzas that we can maybe request for our next meetup. The other thing we've done is we have used multimodal model to extract embeddings on the fly when we were inserting data. So here we use clip, and what that lets us do is it lets us query and specify in text what we want to do, what we want to look for, and we can query the same. We're querying in text, but we get images in return. And somewhere there are pizzas there. I'm sure of it. And then you can do these kinds of queries. In fact, you can find similar faces using, we've indexed all this data into the database already. And what we can do is filter by metadata, so find people with brown hair. Or you can find, these are just different API examples for us. Or you can find people by similarity. So here I'm going to use Taylor Swift, her picture as an example. And even though my smaller data set doesn't have pictures of her, it essentially goes and finds people who look like her. In fact, I want to restrict it further. I want to say I want to find someone who looks like her, but also has brown, straight hair. And that's a much smaller set of 2 people. I'm going to keep it at that for the demo because I think I'm running out of time. And just want to say, we do have a flexible API for for doing approximate and exact searches. You can choose between different algorithms to index, and we are 2 to 4x faster against some popular open source vector databases for multimodal embeddings. I think I'll stop here. There's a lot more I can talk about performance, I can talk about some examples, but maybe real quick, one thing that I wanted to do is show you guys the scan code so that you can There's a lot of things that we are building. We're building new demos, which we would love to get your feedback on. You can go on our website and request one of those demos that I was showing you. There'll be a lot more use cases and integrations. So please go ahead and write to us. You can scan the QR code and reach out to us. Thank you.
Thank you, Vishakha. Do we have any questions for her? Ooh, okay. Rocky? Sorry, behind you.
Hi, Vishakha. Does the size of video embeddings scale linearly
with frame rate? That's a great question. I don't have an answer to that myself because most of our customers right now are working with image embeddings and they choose the model and they either do 64 or 128. Some of we ourselves have indexed 4K dimensional embeddings, but I don't know if there's a correlation. All I know is the more accuracy they want, the higher dimensions they go with, but then there is a point of diminishing returns.
Thank you. Could you press the button? Yeah.
Sorry, I came in late. I think it's a great talk. That's why I'm here. So does Postgres SQL with its embeddings, vector embeddings capability as well? Is it similar to your Aperture database? But you bring more to the table, is that right?
So Postgres, I mean, the fundamental difference that comes is in a relational model that Postgres offers versus the graph model that we do. We do a lot, when we were analyzing what data model to use for the metadata, a lot of the applications, all these examples that I showed you earlier, they fitted a lot better with the graph model. The trouble with classic graph databases used to be scale and performance because they are very connected. That means system-wise, you're pointer chasing kind of workload. But with an in-memory development, which is part of the work that we did at Intel, the in-memory graph can really scale well, and it's the right model for it. So the difference between what Postgres would offer versus what we would offer in terms of metadata management would be that all the differences between a relational and a graph. In terms of the vector support, I haven't used PG Vector myself, so I can't comment on how fast it performs. And we have it in our roadmap to compare performance-wise. But another difference is the support for the data itself. Because we look at Aperture DB as the unifying backend for the entire pipeline, which means we integrate with labeling frameworks, we integrate with training frameworks, inference frameworks, so we can feed data in batches. So data, by data, I mean actual images or videos or documents that people request. We can feed those to these models, to these model frameworks directly. That sort of support you'll have to build on top of something like Postgres. So then you end up doing all that work and you'll get to the spaghetti diagram. That's essentially what you're choosing between.
Do we have any other questions? All right.
All right, thank you.
Let's hear it. Thank you, Vishakha. Next up, we have James Lee from 12 Labs.
Turn on. Hello? Got it. All right. Hey guys, I'm James. I'm the head of the developer experience at 12 Apps. So yeah, so this meetup, obviously we have like speaker from, from a more like observability infrastructure point of view. We have speakers from more like intro to natural language model, beginner introduction point of view. We have like a talk from like a database infrastructure point of view as well. So my talk will look at the evolution of the world, mostly from the foundation models perspective. And it's great that Vishakha is talking about multimodal data in the previous talk, because that's going to be a big part of my presentation. So this is the quick agenda of how I'm going to cover the talk, starting with the evolution of video understanding as inspiration from language and image understanding. Then we'll look into video foundation models with video embeddings, and then conclude with the very exciting cutting edge video language model with multimodal large language models. So yeah, let's dive into the first section. So the evolution of machine learning models for language and vision has seen a lot of advancement in recent years, thanks to the introduction of the transformer architecture. So like for NLP, previously a lot of work was focusing on like recurrent neural networks and some of the variants like long short-term memory and get recurrent units. But over the past few years, since the invention of transformer, like most of the work on NLP has leveraged this architecture, right, to solve different NLP tasks. And similarly, we can see that thing happening in image understanding, right? This convolutional neural network, which has been very popular since 2012, and then lately there seems to be a shift that focuses on vision transformer that can basically adapt transformer architecture to work with image. And the foundation of transformer enable what a lot of people now call foundation models. And these foundation models for text and image enable a lot of like interesting embeddings and generative use cases that are disrupting vertical specific application development. So for example, like a model like BERT, right, from Google, they focus on embedding use cases that can generate contextualized word embeddings from large scale unsupervised data. And those embeddings can be used for different NLP tasks like classification, sentiment analysis, and name entity recognition. On the other hand, GPT family models or some of the latest work in diffusion-based architecture like DALI or Stable Diffusion, they power generative use cases, and that included generate like net new text or image from scratch given an input, and that have power a lot of downstream tasks like summarization, visual QA, and generating visual generation. So you can see here on this type, like this model can be rough as an API for its downstream tasks, and those API can be consumed, for the application layer, right, from different use cases here, from code generation to copywriting to like search engine, and those application can then be exposed to end users and enterprise. And the key thing of this whole stack is that vertical specific training data as well as compute go like to a critical factor to help with the development of these models, right? So moving on to video understanding, a lot of the work was focusing on this domain was really sort of constrained into specific tasks such as activity recognition, facial recognition, typo estimation, emotion detection, object detection, and even semantic segmentation, right? And all of this type of work really focused on very niche domain of video to help with the analysis of this work. So this is a quick slide talking about like the evolution of video understanding over the years. So video as a modality was invented in 19th century, and back then, in order to consume video, you kind of had to like manually watch through the whole thing, right? And then when the first speech to text model was commercialized in '96, then they used it to basically get transcript from the video, right? To understand what's going on, but this transcript pretty hard to digest and also like disconnected from the visual information. And then since the invention of the first image recognition system back in the late 98, 97, that helped for the the evolution of computer vision, and with neural networks back in 2012, that helped like a lot of work to incorporate neural networks to build computer vision-based system that tackle some of the tasks that I showed in the previous slide, and they generate like text and metadata based on the video itself. But it's important to note that these tags or metadata cannot capture the full meaning or context, and sometimes can create huge discrepancy when you try to analyze it. And so I could argue that the evolution of models for video understanding is going to follow a similar trajectory to that of language and image understanding, with the rise of video foundation models, right? And these video foundation models can emerge to power use cases that leverage, video embeddings, and this model learn from video data using principles similar to those employed by models in text and image. And they can power a lot of downstream video understanding tasks like search, classification, action recognition, localization of temporal ideas, etc. So in this stack, you can see the model under the base exposed as API for the downstream tasks, and that can be exposed as to video-centric application upper layer, and this application can then be consumed by the end users, enterprise, individual users, pretty similar workflow as we see for text and image model. So next, I want to dive deeper into video foundation models and kind of unpack what does it mean to build this type of model. So Vishakha actually got a slide in her previous talk talking about embeddings. So I probably don't have to explain a lot on this concept anymore. But there actually has been a lot of work focused on video embeddings lately, thanks to the rise of multimodal evolution of vector embeddings. So traditionally, these embeddings were focused mostly on text, image, and audio data. However, with the rise of multimedia content and the versatility of the transformer architecture, there's been a shift towards develop embeddings that can capture visual, textual, and audible information all in the shared embedding space. And so, these multimodal embeddings combine these different modalities within videos in order to create a comprehensive representation of the video, and they can enable a lot of wide range application in different domains. And we'll talk about two in particular, video search and video classification. Let's talk about video search, right? So, so imagine you can find a particular video in a vast collection simply by describing some of the visual element or keywords of the video. So video search is the task of analyzing the different semantic information of videos, and thereby enabling efficient and accurate retrieval of specific video content. And they can help play a crucial role in helping users navigate through vast video libraries and discover the video they're looking for without having to watch them. So that's a brief description, and this is the architecture of how video search work for a product. But before talking about it, I want to dive into some of the key challenges with working with video search. So three major ones here, right? So number one is that video often combine both visual and auditory information, and make the search process to be more complex. And additionally, there's this inherent temporal dimension inside a video because things are moving over time, right? And then you have to capture that that temporal dimension as well. And so within this first challenge, right, different modalities may carry different meanings. And so the model need to be able to interpret the overall holistic meaning by considering the different nuances and context of each modality. So for example, if someone, is laughing, but he or she looks sad and also something negative, then our system must be able to accurately determine the overall emotion of that person, right? And that requires, capturing and analyzing the subtle cues and interaction between these different modalities. The second challenge is that understanding, user intent and providing relevant search result is also not an easy task, right? Because interpreting the user queries, user preferences, and the context in order to deliver accurate and personalized video search results often requires very high advanced recommendation and relevance ranking algorithms. And this actually become even more challenging in different domains like UGC, gaming, and sports, because in each of those domains, each of them has its own specific vocabulary, context, and user behaviors. And finally, real-world search applications often deal with large-scale video libraries, and that requires efficient indexing and retrieval mechanism, and also like developing scalable algorithms and infrastructure to handle such a large volume, and the required latency to retrieve the relevant information is pretty crucial for effective video search. So here are some of the couple of use cases of video search technology, right? So the largest video sharing platform in the world, YouTube Prop, it offers a powerful video search engine. As a user, you can search for videos based on keywords, titles, or specific categories. And then there are also exist dedicated video search engine that focus on like specific types of video. And in the screen, I put a screenshot of the web page of the archival site from NASA, where you can like search for any videos related to like very NASA focused topic, right? Like satellite or manufacturing or like going to the moon, for instance, right? And then finally, there's enterprise video search tools. So these are like more for organizations who want to use video search to index and search the internal video library, right? And so these tools can enable the employees to find video or moments within videos for different purposes, from corporate training to knowledge sharing to organizational research. Like all of these search engines that I mentioned here, they do have one limitation with the current approach, is that they rely on keyword matching and metadata analysis in order to like index and retrieve the video. And because of that factor, they're going to miss some important visual and auditory cues that could greatly enhance the search experience, right? So with Twilio Labs, we build like a search API that move beyond the limitation of the traditional search engine. So we like integrate all the available forms of information in the video, from images, sound, spoken words, and on-screen text, in order to like capture these complex relationships among these elements. And also designed to detect some of the finer details frequently overlooked by some of the unimodal methods. And finally, it supports natural language query, making interaction as intuitive as a daily conversation. So that is for video search. The second task we talk about is video classification. So this one really means that you can categorize your videos into a predefined classes or topics. Think about like classify your videos into like sport or news or documentary or entertainment, right? And this helps benefit content creators, video platform, but also enhance the user experience by providing personal recommendation based on their interests and preferences. So with video classification, there's two main challenges here, right? Number one is creating a label data set can be very label intensive and time consuming, right? So, I talk about like how videos contain different visual elements, right? And all of those must be accurately labeled for the task of classification. So like that requires human annotators to carefully watch and analyze the videos frame by frame in order to like assign the appropriate labels, for the task. And then furthermore, I talk about the temporal dimension, how like context in video can change over time, right? So an annotator must consider the entire video sequence to assign the correct label. Second challenge is like that current technology actually relies on fixed taxonomy of classes, and that can be very difficult to adapt to a specific use cases and domain. So, for example, on YouTube, as a content creator, right, you upload your own video in there, and you may want to classify your videos into like some categories. But right now, YouTube only like offer 15 standard categories, right? And those may not be sufficient in order to accurately classify the diverse range of video that was being produced. And so this limitation really highlight the need for a more flexible and customizable classification system that can better cater to the unique requirements of different industry as well as content creators. So video classification has a bunch of different use cases. Let's see a couple on the slide. Surveillance, security, it can help with detecting anomalies, recognizing suspicious activities. There's content moderation when you want to enforce community guidelines, detect inappropriate or harmful content, right? Spot analytics when they can categorize players' action and movement during the game. There's automated video and editing, right? When you can identify and segment different scenes or events within the video. And also contextual advertising, where it can help advertisers to target the audience more effectively and deliver personal ads, right, that align with interest and the context of the video content. And one major limitation with all the system is that, as I mentioned in the previous slide, they are very constrained to a predetermined set of classes. And so, with 12 Labs, we have this classify API that allows you to, customize your classification criteria without the need to retrain your model, right? Essentially, you define group of classes and you can craft your own prompts that define the characteristic of each class. And this prompt act as the building block of the system, and it will help you get a precise placement of videos into relevant classes based on their content. So this one is more talk about cutting edge and what's going on in video understanding. So I talk about video prediction models, but then also there's been like a whole new world research in video language model, and that follow a very similar trajectory to like the evolution of LLM as well. And this model has been trained on like large amount of data on video and text description. So I want to talk about the rise of like multimodal LLMs. So how they're different from like traditional LLMs, right? So traditional LLMs are trained on text data, and as a result, they do have a limitation in handling multimodal data. And so multimodal LLMs, right, because they train on different type of data, they can process different type of data using the same mechanism, and therefore can lead to more accurate and better contextual output. These two figures come from a survey paper by Microsoft on multimodal foundation models. The left one shows the search paper on large multimodal LLMs from March to June of 2023. And obviously, there's been a lot more exciting work in the past 4 months. And the right figure is the summary and categorization of different papers on large multimodal, right? Tackling from different approach. You can see here from in-context learning to adaptation to evaluation, as well as agent, right? So obviously, there's a lot of exciting work that in multimodal LLMs, in the past few months alone. So video language modeling is a subset of multimodal LLMs, and that entails understanding and generating text summaries, description, and response based on the video content. And this is pretty important for like holistic video understanding because it helps bridge the gap between visual and text understanding. So the diagram I shown here in the slide is a description of like 12 Labs' latest video language model. It's called Pegasus. It's an 80 billion parameters video language model, and it can help enable like different downstream tasks, right? Such as video description, video summarization, and video question answering. So I want to talk about these three separate tasks, and then now we're going to explain how it works. So a video description produce a description of stories of a video expressed in natural language. Video summarization generate concise text summaries based on the content of the video while preserving the essential information and the key moments. And both of these tasks, right, you can think about the key benefits. They can help improve video comprehension for the viewers, especially when, let's say, someone like cannot see or cannot hear the video. They can also like help keep viewers engaged by providing additional context and information that they might not have otherwise noted. So a couple of key challenges with description and summarization. Number one, videos contain diverse scenes, action, and events, and therefore it's quite a challenge to generate accurate and comprehensive description and summaries. Again, that part about temporal alignment I cannot stress enough. So you have to like align the description and summaries with the corresponding video segment. And so to achieve that precise temporal alignment is really hard, especially when you think about like fast-paced video like action movie or like complex video content, right? And then finally, I guess related to that part is that like the generate description and summary must be coherent and contextually relevant, right? Three major use cases I want to highlight here for this task. So in media and entertainment, they can be used to create previews or trailers for new movies, TV show, and other video content. In e-commerce, they can be used to enhance the shopping experience, right, by providing summaries or highlights of our product video. And then even for marketing advertising, they can be used in campaigns, right, to create engaging and informative video content. Now the task that's like somewhat related to the previous one is video question answering. So think about as a chatbot that can answer a question related to the videos through semantic reasoning between visual, linguistic, and sometimes like audible information. And so they can help provide, basically make the videos more accessible to a wider audience, right? Think about like, people who speak in different languages, right? And then also provide interactive elements that allows users to interact with the content. So to key strands here, it requires, multimodal understanding, right? Different integration, different modalities, as well as temporal reasoning part I'm been emphasized throughout the talk. And then highlight a couple of like use cases here. Provide custom support through video chat or messaging. Create interactive additional content or create interactive media experience, such as for like gaming or VR experience. So our team recently released like a new video to text API that was based on the multimodal LLMs that I provided in the previous slide. And we offer it as like 3 separate API. The gist API can produce concise text output based on the video, like the titles, the topics, and the hashtag. The summary API is designed to generate video summaries, chapters, and highlights. And then for some more like customizable output, we have the generate API that allows you to prompt specific formats and style, from bullet points to reports to even creative input like song lyrics, right, based on the content of the video. So this is like a quick recap slide of what I talked, right, from that evolution from foundation models for text and image to video, unpacking how foundation model works, embeddings, and how that power search and classification, and then also the cutting edge video language model that enable use cases like video description and summarization QA. I definitely want to like show a quick demo of how LLMs work to like display like some of the tasks we were able to accomplish based on the content of the video. Based on the content of the presentation that I just present. So let's be sure the sound here is available. Yeah. So this is like a 4-minute video by our product manager talking about 3 capabilities of our product: video search, video to text generation, and then video assistant. Second.
All the elements inside the video, including visual conversation, text and video, and run logo, in order to power many data. Hello, my name is Sunny from 12 Labs. Today, I want to talk about 3 capabilities that are powered by our multimodal AI. When we talk about video understanding AI, we can already take into account all the elements inside the video, including visual conversation, text and video, and run logo, in order to power many dashboard tasks. Let's take a look at video search. First, you have to walk through all of the video content in order to find a specific moment where AI people going into local. Instead of having to spend hours on this, as you can see, you can do this with 12 apps in just a second. All you need to do is to enter a natural language queries instead of having to type in a keyword from the metadata. All right, the second thing I want to mention today is the video to text generation. With our generate APIs, you can translate all of the video content into textual formats for choice. There are a couple of things you can do here. First of all, you can use a 12-app templates in order to generate summary, highlight, or chapters. Let's take a look at this CCTV footage. As you can see in just a second, you can already draw the most important content out of this video. It's so easy for your end user to consume this video. You can also generate a free-form text format output from this, such as write a police report. Usually, this task will take so much time for a human to be able to go scene by scene frame by frame to not miss any content. But as you can see here, with 12 labs, you can do that in such a few seconds. All right, let's take a look at another example in healthcare. What type of instruction video for the VR? I want to write a step-by-step instruction. Here's CPR based on the video. There are endless of possibilities that can be powered by this feature, as you can see. Last but not least, I want to introduce a new brand new video chat interaction so that you can interact with video content so easily. So let's take a look at this footage over here. This is a complex sports scene that has so many players involved. I want to then search for a very specific detail, which is the key player. Who is the key player inside this video? Let me show you the difference between what TalLab does and other models. For video understanding from TalLabs, you can see that our model can correctly detect who is the key player in this video, which is completely missing from model just used on ASR or transcription. Or in video lama, the detail is also completely missing. Our model also very good at understanding temporal information and scene by scene transition, not just rely on the image-based or static content. So for example, I want to understand what is the sport frame being promoted in this video. So the model can detect correctly the scene where a sports frame being featured, and then also understand the transitioning of the scene before and after that. This detail is completely not achievable by ASR model and video llama as well. Thank you so much for your listening.
Yeah, so that's the a quick demo of how like this API works, and this is a quick recap slide about product roadmap. Like at a high level, we focused on these three pillars, starting out with building the building the state-of-the-art video language model that can really capture complex videos, and then we expose them as API as a form of like search, classify, generate, and probably like fine-tune API next year for more enterprise use cases. And then the last part is developers, right? Want to offer them so that developers in this organization take in our API and then build video understanding application in their respective organization. Things like semantic search, content moderation, summary generation, video QA, etc. Yeah, and we have like diverse use cases across different domains, as you see here, from arts to movies to gaming to lectures and meetings, security as well. So yeah, if you want to try out our product, you can go to the URL I put in the slide. We also have a Discord also around this Discord community for 12 labs called Multimodal Minds, where we gather folks to discuss like the latest and greatest of papers, projects, or product release related to multimodal. And we also been hosting a weekly virtual webinar series where we invite a lot of like the founders, operators, developers in the space to talk about their work. And actually, Vishakha and Fabian, both of the speaker today, was one of our previous speaker, in previous months. So if any of you are working, in multimodal and interested in sharing that with our broader audience, please email me. My email is on the top of the slide, and my Twitter as well. Thank you.
Thank you, James. Do we have any questions for James?
Okay, so James, in future, do you folks plan to create a marketplace as such? There could be many, many use cases here. And let's say on a specific domain, even it's about learning or something, but if you're fine tuning API and coming with an end-to-end application, do you have a plan to make any sort of a marketplace for your product in future?
Yeah, so I think like the analogy that I want to make like is just like how OpenAI build foundation models for language understanding. We are building foundation models for video understanding, right? And I think for now, like we want to stay at the horizontal infrastructure layer that power different downstream tasks. And maybe down the line, as we have more use cases, just like OpenAI has the custom GPT, right? With all the plugins, that option. Yeah, we might considering that, but video is a different type of modality, and I think hopefully we get to the point where there's enough demand for our model and API in order to expose that to that many use cases.
Sure. So for now, you are sort of, your pricing model is like you charge based on the transactions. That's the.
Yeah, so pricing mechanism is like classic usage-based pricing, right? Number of like hours of video being uploaded, the number of like codes, let's say for like generate like how many tokens they use for the prompt, etc. Yeah, our goal is to like keep the cost as maintainable as possible. Obviously, building models and have the infrastructure to handle video data is like 100 times challenging than image and text. But yeah, hopefully we will get to the point where like just consumer can start easily like search and interact with your video in a economical way.
Any other questions? All right. Thank you so much, James, for the talk. Thank you, everyone, for listening in. I ran the raffle, and I have a first winner, Paul Martin, if he's still here. Oh, perfect.
Thank you.
Second one is Gain B. All right. Thank you, everyone, for attending, for your questions, and thank you to all the speakers who were here. And yeah, feel free to go around and network till 8:30 p.m. before the office closes. Thank you so much. Hope to see you next month, right here again at the same time. Thank you.